Hi guys, maayong adlaw. Welcome to NatzMath TV. For today's video, my presentation is about writing statements to symbolic logic and vice versa. This is the continuation of the topic in my previous video about operations with propositions. In that video, I had presented to you about the different symbolic logic used to represent a proposition. Now in this video, I would be presenting to you about how to write logical statements to symbolic logic and vice versa from symbolic logic to logical statements. So to start, let us have our lesson objectives first. At the end of this video, you should be able to symbolize propositions, perform the different types of operations on propositions, and write logical statements to symbolic logic and vice versa. Before we go to our examples, let us review first this table. So we let P and Q as our proposition, or we let P and Q as our propositional variables. Then we have here the different types of propositions. We already have discussed this one, which is about the conjunction, disjunction, implications, biconditional, or the negation. When I say implication, this is just the same as when I say conditional statements. So from these statements, we have here what we call the symbol referring to these types of propositions. So for and, we use this symbol. For disjunction, we use this symbol. For implication, we use this arrow. For biconditional and for negation, we have either this symbol or this symbol, but for this video, we are using this symbol. Now, this symbol is used to translate the worded statements or propositions to symbolic logic. These are what we call the different symbolic logic given the different statements. So for example, if you are given P and Q, since this is a conjunction, so we use the word and as our connector. So that's why we use this symbol P and Q. And the same also to the rest of the different types of propositions. Okay, so let us proceed to our first example. We let P, today is Monday, we let Q, tomorrow is Tuesday, and we let S, the day after tomorrow is Wednesday. Now we have here the different simple statements, P, Q, and S. So we have three variables. Now our focus is, given a compound statements coming from these simple statements, we need to write our symbolic logic that represents the compound statement. For example, we are given this statement, today is Monday and tomorrow is Tuesday. This is a compound statement, of course, taken from this given. So if we are going to analyze the statement, this statement, which is today is Monday, refers to our P, and this statement, tomorrow is Tuesday, refers to our Q. And since this is and, of course, this is an example of a conjunction. So we will be using a symbolic logic to represent this statement. We will have this symbol. Today is Monday, which is our P. And since this is a disjunction, of course, we will be using this symbol. This symbol represents the and. And tomorrow is Tuesday is Q. That's why we have this symbol P and Q. This symbol represents this compound statement. Now let us have the second example. If we are given the day after tomorrow is Wednesday, if and only if today is Monday. So as you have observed, our connector is if and only if, which is an example of a biconditional statement. So if this is a biconditional, of course, when you write this statement into symbolic logic, this statement, the day after tomorrow is Wednesday, represents the S, and today is Monday represents the P. And our connector is if and only if. So when we write this one to symbolic logic, we will have S, if, and only if, P. Okay, next statement. If today is not Monday, then tomorrow is not Tuesday. So as you have observed, this statement is an if-then statement, which is an implication or a conditional statement. Now, aside from that, we also have here the word not and the word not, meaning our P is being negated and also our Q is being negated. From this statement, today is Monday, which is a positive statement, then we have embedded the word not in this statement that becomes negative. So the statement is being negated. So P is negated and also Q is negated, but we have the implication statement. So when we write this one into symbolic logic, so we can have this symbol. Since this is an implication, we use this arrow, and our P is negated, and also our Q is negated. Okay, next example. Today is Monday, or tomorrow is Tuesday, and the day after tomorrow is Wednesday. Again, this statement is a combination of a simple statement and a compound statement. As you have observed, the first statement, today is Monday, is our P, which is not negated. So this is P, then we have the comma. The comma in a statement, especially if that is a combination of simple and compound statement, has something to do with a grouping symbol. Okay, and we have here the connector or and the and. Then tomorrow is Tuesday. This statement is our Q. Then the day after tomorrow is Wednesday, which is our S. So if we are going to write this one into symbolic logic, we will have the symbol. The P, which is this statement. Then this symbol or, because our connector here is or. Tomorrow is Tuesday, which is our Q. And which is our connector for conjunction. So we have here the S, the day after tomorrow. Let's have this example. It is false that today is Monday or tomorrow is Tuesday. Now, in this statement, we have here the statement today is Monday, which is our P, and we have this statement tomorrow is Tuesday, which is our Q. Because of the word it is false, it goes to follow that the rest of the statements is being negated. P is negated and also the Q is negated. Even if we do not have the not word in the statement, but because of this, it is false that today is Monday or tomorrow is Tuesday, this statement negates the succeeding statements. So we have, if we are going to write this one into symbolic logic, so we can have not P, not, then enclosed with a parenthesis, we have the not enclosed with a parenthesis, the P which is this statement, and or which is this statement. Now let's proceed to example number 2. We have this statement, let P, I am innocent, let Q, I have an alibi, then we let R, I go to jail. Now this time, we will do the reverse. We will be given a symbolic logic, then we need to translate this symbolic logic into statements or compound statements. For example, we are given this symbolic logic. P or Q implies not R. So observe, our R is negated. I go to jail, so we need to negate this statement. Then P or Q. And of course, the dominant symbol here is our implication. So this is an if-then statement or implication or conditional statement. So when we write this one into logical statements, so we will have if I am innocent, so if then, because this is an implication. I am innocent, which is our P here, or this is symbol, I have an alibi, which is our Q. Now, because of this parenthesis, meaning this compound statement is being grouped together, that's why we have the comma here. Okay? If I am innocent or I have an alibi, then I don't go to jail. I don't go to jail, that's because our R is negated. Now, next example. We have here P and not Q implies R. This time, Q is negated. Similarly, we have here a grouping symbol parenthesis, then this is an implication. So, when we translate this one into logical statement, we can have, if I am innocent, so our P, if I am innocent, and I don't have an alibi, comma, then I go to jail. Q is, I have an alibi. Since in the symbol it is negated, that's why we have here, I don't have an alibi, then I go to jail. Next, symbolic logic. the negation of P and Q or R. We have here not P and Q or R. Unlike with the first two statements here, we have this implication. This time we have the or. So when we translate this one into logical statement, we can have I am not innocent because P is negated. So we have here the P. I am not innocent. And we have here the symbol and. I have an alibi because this is Q. Our Q is I have an alibi. And comma or I go to jail. So the complete translation would be I am not innocent and I have an alibi or I go to jail. Next example. P and R implies not Q. This time our Q is negated. So when we translate this one into logical statement, we can have, since this is an implication, so we will have if I am innocent, which is our P, and, so this is and because of this symbol, then I go to jail, which is our R, then, comma, I don't have an alibi because Q is negated. So the complete translation would be, if I am innocent and I go to jail, then I don't have an alibi. Next example, P or the negation of Q and we have the R. So when we translate this one, we have, if I am innocent, comma, or we have here this symbol or, then the negation of Q, I don't have an alibi, and I go to jail. This is N. So the complete translation, I am innocent or I don't have an alibi, and I go to jail. Let's proceed to our next example. For example, we are given the statement and we need to translate this one into symbolic logic. Okay, so translate to symbolic form. If you sing and dance, then you are smart or beautiful. As you have observed, the first in the antecedent or in the hypothesis is composed of a compound statement. And the same also with the consequent composed of a compound statement. So we need to dissect this statement one by one. As a whole, this is an if-then statement, which is an implication. But in the antecedent or in the hypothesis, we have a compound statement, and also in the consequent, we also have a compound statement. In this statement, we have here the connector and, which is a conjunction. So we need to dissect this one. We assign a variable to each of the simple statement. For example, we let P as you sing. This is our first simple statement. And we let Q as you dance. These two variables represents the antecedent, you sing and dance. Then for the consequent, we will have here, we let R as you are smart. Then we let S as you are beautiful. So when we write this statement into symbolic logic, we will have first P for the first simple statement, you sing. Then we have the word and, our connector for conjunction. That's why we have this symbol. Then we have the Q, which is you dance. P and Q represents this statement here. You sing and dance. Then, since we have the if-then statement, so our symbol used here is an arrow. Then we group these symbols. Then we proceed to the consequent. We have here the R, which represent the statement you are smart. Then we have a connector or, we have this symbol. And of course, the last statement, which is you are beautiful, that represents the S. So therefore, when we translate this statement into symbolic logic, we have P and Q implies R or S. Next example. Translate to symbolic form. The same, this is an if-then statement. If I recite the preamble, then I will pass the subject and I will get 90. So, Let's dissect this statement one by one. We will have the first simple statement. I recite the preamble. We let this statement as our P, and we let Q, I will pass the subject. Then we let R, I will get 90. As you have observed, this is a conjunction because of the word and. So if we are going to write this one into symbolic form, we will have our P, I recite the preamble. Then since this is an if-then statement, so we'll have the arrow. Now as you have observed, I did not use a parenthesis here because this is just a simple statement. Unlike with the example earlier, using undance, it is a compound statement followed by a comma. That's why I enclosed that one with a parenthesis. This time, P is a simple statement. That's why this is standalone statement. Then we will have this compound statement that is being connected by the word and. So we will have this symbolic form. Q and we have the R. So when we translate this statement, if I recite the preamble, then I will pass the subject and I will get 90. This is P implies Q and R. Okay, I hope you learned something from this video. Okay, thank you and God bless.